posterity,
So
Derek.
sorry.
Um, okay. Um, yeah, so all right, so let's start. So yeah, so we're going to start probing BERT embeddings from the very first slide. Here we go. What you're seeing here is a TSNE graph, a dimension reduction of the of a bunch of BERT embeddings. And I don't worry, I'm going to take a step back and explain what's going on here. But from the very first slide, I want to give you a sense of what we're going to be looking at here. Um, so what this graph represents is 10,000 sentences in which the word shin mem occurs. Um, and where I've run each of the sentences through BERT, and then I've plotted the resulting embeddings with the dimension reduction algorithm to show the distribution of the embeddings overall, and that gives us a sense of how BERT organizes its embedding space. And that's what we're going to be looking at here. We're going to be looking at a whole bunch of visualizations of this sort, and uh, we're going to be delving into them to understand how BERT works internally. So now let's take the step back. Sorry. Um, what we're going to see on in cases like this, in this particular case, is that the BERT embedding space ends up clustered into clusters that represent the different usages of the word. So for instance, here, the blue cluster ends up representing sentences like you see on the right, Lo nitkalti sham begader sham ani nefgash. That's the cluster of sham. The red cluster has the instances of shem. Shem mishpacha, shem code. And the brown cluster, which here is represented partially on the right and partially on the left, but that's an artifact of the dimension reduction, and really they're the same cluster in high dimensional space. There, what we have is sum, the verb to put. Achshavu sam lahem me'avirim. Now, here's the
Avi,
miracle. Yeah,
sorry, can you translate all the other examples as well?
yeah, absolutely. Yeah. So the word shin mem has three usages. It can be a adverb meaning there, and that's the blue cluster. It can mean a name, and that's the red cluster, and it can be a verb meaning to put, which is the brown cluster. So these are three very different usages of the word, and they're represented in this embedding space here, right, where each dot is one of these 10,000 usages, which I took at random from a large corpus. So there's a natural distribution here, and it's the dots here. Not only do the dots, not only do the clusters represent the different usages of the word of this homograph, but the size of the clusters that you see here in the graph also represent the natural distribution of these three different usages. Meaning, because I took these sentences from the wild, and because you see the relative size of each cluster, you get a sense of the relative size of each of the usages of the word. Now, here's the miracle of BERT, and why this is so exciting and useful, because what you see here in front of you, this graph with the blue and the red and the brown with these clusters that represent the different usages of Shin Mem, this was created completely automatically, completely unsupervised. Meaning, I took the script that I wrote to do this, and I plugged in the word Shin Mem, and the result was this graph. There was no human tagging. The only input that it had was a corpus of unvocalized Hebrew, just a corpus of newspapers and Wikipedia and literature and so on. And the script automatically found 10,000 instances of Shin Mem, ran each one through a Hebrew BERT model, In this case, we're using BERT, which is a model that we published some time ago. Um, and then I ran an auto clustering algorithm with a heuristic, an automatic heuristic to choose the optimal K for the clustering. And the result is a clustering which really pinpoints for us the different usages of the word and their natural proportions. Okay, so this is absolutely miraculous. So just to take a step back, what we're talking about, I wanted to start with the fun slide, but what we're talking about here is the algorithm BERT, which stands for bidirectional bidirectional encodings and so on. This article by Devlin, which came out a few years ago from Google, and what BERT does is that it trains a language model. It trains a language model based on a what we call the MLM objective, the masked language modeling objective. So given a sentence like this one, and I'll read the first few words, Hasfarim Harishonim Higiu MiBritanya in 1801. This is a sentence from Wikipedia about the Library of Congress. The first books came from England in 1801. It's trained to fill in any word in the sentence given a mask. So if we mask the second word here, it fills in possible ways to possible words that could fit within that point of the sentence. So it could be the first books, Asfrim Harishonim, Asfrim Mekorim, the original books, Asfrim Halalu, these books, and so on. That's what BERT is trained to do. And in a previous lecture, 2 weeks ago, I focused in on what these particular predictions can tell us. But in this lecture here, we're going to look at the embeddings that underlie this system. Because how does BERT get to these words? How does it predict it? Well, given a mask and given the context on either side of the mask, BERT generates a 768 dimension embedding. And this for BERT base, there are smaller or larger models, but in the standard BERT model, you have 768 dimensions, and BERT produces a vector, an embedding of that size, which is essentially a point in high dimension space. And then the predictions are the other points in the high dimensional space which are closest to that predicted vector. So what we're doing in this lecture is that we're probing those high dimension embeddings to see how they're situated in the high dimension space, and what that space can teach us if we use those embeddings directly. All right, so to come back here, what's happened here is that I took each of those 10,000 sentences, generated an embedding. I put a mask on each instance of Shin Mem, generated an embedding for it, and then I took those 10,768 dimension embeddings and ran them through a clustering algorithm, and then plotted them in 2 dimensions here, and that's where we see these clusters. The colors for the clusters, I should say, emerge from the clustering algorithm. Okay. Now, so what else can this do? I mean, these three usages of Shin Mem, the adverb and the noun and the verb, they're so well differentiated in terms of their syntactic function that we could say that's a pretty easy one for it to do. But let's try another one. So here's the word mem mem nun hey, and here's the resulting clustered embedding space from BERT. Now, what are these clusters? Well, the red cluster, the tiny one on top, is the verb appoints, like habank mimaneta directorion, the bank appoints its board, or maduhu mimaneota, why does he appoint her, and so on. These are sentences from the corpus, as opposed to the green and yellow clusters, which are the preposition mimena. Now we see here that the distribution is it's quite unbalanced, right? Mimena, the preposition, is a very, very common word in Hebrew, and mimaneh, the verb, is a minority usage. It's a much more rare case of that of those letters. So this is also part of the miracle of BERT, that if we were to just take a large corpus and say we want to find all the instances of mimaneh as a verb, we would it would be extraordinarily difficult to find it. That would be one of those needle in a haystack type of cases where we would have to comb through thousands and thousands of examples just to find a few actual examples. If we were a few actual results, if we were searching just for that string of mem, mem, nun, hey. But what BERT does is it immediately breaks down the cluster, it breaks down the embedding space into these clusters. As you see, like I said, it's completely unsupervised. That red cluster was identified automatically by the auto clustering algorithm. And there we have a huge, a large batch of instances of mimena as verb. But what's more interesting, and you're probably wondering, well, why was the preposition mimena broken down into two clusters, right? Why is there a yellow and a green? Any ideas, suggestions?
Because
Sorry?
you use the number of the clusters that you enter to k-means, maybe.
Yeah,
If
okay.
you reduce, maybe they will be combined.
That's true, but again, with the script that I wrote to generate this, generates it in many different Ks and then finds the optimal one in terms of how tight the clusters are. So if it was really one usage, they would likely be a single cluster. So it's not just an artifact. Usually these clusters actually represent something. So in this case, so I was surprised at first also. I was like, oh, why is it divided into two clusters? And the answer, once I looked at the examples, it became clear. These are two examples from the green cluster. The coming and going from it are possible only in this way. Or kulam yotzim mimena mafsidim, everyone comes out losing. Again, from it, everyone comes out from it. Now look at the examples from the yellow cluster. Nishmad vika badelet, mimena nisiti letalem. Right, we heard a knock from the door, at the door from which we ignored. Or alon tavakia chevra mimena putar lo tishtamesh bishmo. And he sued that the company from which he was fired should not use his name. So there are two very different usages here of mimena. One is from it, and the other is from which. Meaning, in Hebrew terms, in the yellow cluster, there's a relative clause. Mimena is acting as a relativizer, beginning a relative clause, meaning it would be a place where editors would always add a shin azika, so that it would say shemimena nisiti or shemimena putar, right? It's acting as a relativizer, whereas in the green cluster, it's simply a preposition without any relativizer. So these are very different. It's subtle, but it's a real difference in how it's used, and BERT nails the difference in the clusters. So this shows how delicate the distinctions are that it is capable of finding. Well, so now let's try a semantic distinction from the Evan Shoshan dictionary. So I leafed through the dictionary and chose one at random. Here's halaklak. So the word halaklak has two definitions, as you see here. There's a 1 and a 2. A 1 is halak b'miktzat, meaning slippery or so somewhat slippery. And number 2, b'hashala, meaning metaphorically, it's used as savua hanfani armumi, as someone who's sly or shady. So let's see what BERT can do with these two. So I ran the word halaklak through BERT, and BERT created these clusters that you see here. So let's look at the three largest clusters here. The green cluster gives us bimidron halaklak, midarder bimidron halaklak. He's rolling down on this or deteriorating on this slidey surface, on this slippery slope. We say, right, is the right translation. Or the I didn't, sorry, Virat, I didn't prepare the translation, so I'm doing that on the fly here. Chayei mitnalim al kvish chalaklak, on this slippery road, or hamidron letimtum korrektivi u chalaklak. This slope is a slippery one. So that's the first definition, right? It's like physical slipperiness, and then we have the purple cluster over here. Now let's look at those two sentences. Lamrot heyoto chalaklak d'marit ayin. He seems kind of shady at first look, or hu itvalet kesocher mavrik ach chalaklak v'shachtzan. Right, in the purple cluster, the purple clustered together sentences in which the word chalaklak is used as a negative attribute of a person, which is the second definition in Evan Shoshan, right? To remind you, where do we have it? Right, we had over here two definitions in Evan Shoshan: the physical slipperiness and the metaphorical application to as a description of a negative attribute of a person. And that's what BERT did here. It took those two usages of chalaklak, even though they're both adjectives, and even though they're both spelled, they're both vocalized the same way, BERT separated the two of them into two clusters. Now, what's even more interesting is that we have a third cluster here, the red cluster. And let's take a look at what that has. It has a bunch of sentences like the following: Amadnu al kerech chalaklak. We stood on slippery ice, or hakvish haya chalaklak. The road was slippery. So what happened here? Well, the red and the green are both instances of the first definition in Evan Shoshan, right? They both are cases of a physical slipperiness, except in the red cluster, it's about a physical item in the world. And in the green cluster, it describes something physical, which is itself a metaphor, right? It's a midron chalaklak or a kvish chalaklak, the slippery slope or the slippery road, which themselves are then metaphors for something else, for someone, for this sort of deterioration and so on. But, and that's as opposed to the purple cluster, where there's nothing physical in the space, but rather the word chalaklak is just a direct adjective to a person. So I think BERT actually defined the space in a way that's more precise than the Evan Shoshan dictionary. And it captured the distinction Evan Shoshan talked about and took it further. And that's what that's one of the really exciting things about BERT. Now, let's take it further. Can we even see some slang? So let's talk about the word dachuf. Dachuf is a really interesting word because of how it's evolved in Hebrew dictionaries. So I have here on the right, we have the Evan Shoshan dictionary, the traditional one from the one that Avi Shmidman put together, and there we have he breaks it down into four, but it's essentially all adjectives. He uses the chuf as an adjective meaning important or urgent and so on. Now, in the 2003 edition of Evan Shoshan, after Evan Shoshan's death, posthumously, the editors added another definition. So take a look at this last definition here. As you see in the highlight, it says toar hapoal, taf hey pei, meaning not just an adjective, but now it's being used as an adverb. This is a new usage of the chuf that they attest in the 21st century edition. And his Evan Shoshan's, or the editor's definition here is ze b'dchifut, meaning, and he gives the example of dachuf li shetishlechi li et hamechtav achshav. It's urgent for me that you send it. So the words dachuf li, right? It doesn't make sense for that to be an adjective because it's missing its head noun. So he adds the ze, meaning if I say dachuf li shetishlechi, it's as if I said hadavar hazeh dachuf li. And the noun, the subject, is missing because the chuf encompasses the noun and the adjective all at once. Now, in the Milona slang of Rubik Rosenthal, we have another usage, which I think we're all used to just from common parlance, and that's as an adverb, just meaning bidchifut, meaning it's not replacing hadavar hazeh dechufli, but it's just stuck in the middle of a sentence next to a verb to directly modify the verb. So, and the example Rubik gives is Ata chayav dachuf lasot mashahu. You have to urgently do this. So dachuf has started meaning meaning urgently, not urgent, meaning in Evan Shoshan's lifetime, it just meant urgent. Now it means urgently, and it can be applied directly to a verb. And in between, we have that Evan Shoshan entry where it means zed dechuf, but it's not exactly, it's not a full adverb. Okay, so we have these three usages of dechuf, and now let's see the clustering. I ran 10,000 sentences. I got this clustering, and let's look at the clusters. The yellow and the green are the standard adjectival usage that Evan Shoshan knew about in his lifetime. Yesh tzorech dechuf, there's an urgent need. The blue cluster is cases like hayad dechuf lo, it was urgent for him, or lama dechuf leVerkovich, why is it urgent for Berkovich? So that's the usage that Evan Shoshan, that was added to Evan Shoshan, where dechuf lo, like this thing is dechuf for him. But then the orange cluster, and this is a tiny little cluster, at least in because it's mostly used in spoken Hebrew, but it was attested enough in my corpus to get its own cluster in the bottom left over there. The orange cluster has these cases, for instance, I'll read the last one here. Penei dachuf leRav Litzman, right? Go immediately to Rav Litzman, go urgently to Rav Litzman. So that's the Rubik Rosenthal usage, that's the slang usage. And what we see here is that BERT was capable of automatically presenting us with these clusters, which break it down into these different usages of adjective, on the one hand, and then the middle category of a sort of adverb, and then the full adverb, where it just means urgently, as we see here attested in the orange cluster, and as Rubik Rosenthal told us about in his slang dictionary. So BERT is capable of identifying these semantic distinctions that we see in dictionaries, and even those found in specialized dictionaries like the slang dictionary. Now, how can we leverage these? So I think I already hinted to the fact that it can help us find minority cases. Lexicographically, it can help us. Like if we have the word chet bet reish vav, one of the things that's puzzling, or that's always confounding when doing lexicographical work in Hebrew, is that there's so many theoretical options that don't actually come to the fore. Like chet bet reish vav, I could vocalize that in a dozen different ways, but how many of these really occur in actual Hebrew? And the answer here, as is the answer with almost every case, with almost every word in Hebrew, is that most of the options don't actually occur. Most of them are just theoretical. But how do you figure this out? So the way we figure it out is by running a BERT. I put in, here to make sure I was covering, I put in 50,000 sentences of chet bet reish vav, clustered them, and we have our major clusters. The first one, the red and blue together, are the very common word chavero, meaning his friend. Chavero me'el tam ha'yamim, and so on. Chavero me'el tam ha'yamim. The purple, his friend from those days. The purple cluster is the word chavru, the verb of they connected. Kach chavru lehem biyachad, they connected together, they came together. Shnaim chavru litzemed, they became a pair. And then the light blue cluster over here, all the way on the left, is the imperative chabru, like someone saying to someone else, go connect, as in lo nara chabru et hakabel. It's okay, go just connect the cable. So what this gives us lexicographically is a narrowing down of the three usages that actually occur in practice. And it gives us the relative proportions, which I put over here next to each cluster, 78% for chavero, his friend, 20% for chavru, for the verb, and 0.5% for chabru, for the imperative. And the reason why this is so exciting is that Hebrew dictionaries across the board do basically shirk the responsibility of telling us the relative distributions of the words in Evan Shoshan or Rav Milim or any of those dictionaries. They'll present multiple usages of the word, and only rarely will they say this is the more common usage. Most of the time, the dictionaries just give us all the possible options without indicating that this one is used most of the time, or this one is used only in a small minority of cases. And BERT gives us the ability to fill in that information. I think the reason why it's not there in the dictionaries is that it would have required so much spade work in order to make those determinations. And now these determinations are available to us, and to lexicographers automatically. We could publish a whole supplement to the dictionary with adding the relative proportions, which were never attested before. Okay, but this is just lexicography. There are so many more exciting things that we can do with these BERT embeddings, and I'm going to give you three ways to take these embeddings, look at them from another angle, and do useful things with them. So the three things are a thesaurus companion, evaluating the interchangeability of synonyms, to create an editor's companion to evaluate editorial directives, and to create a reader's companion, where we highlight unusual usages in a text. I'm going to show you how we do this right now. Okay, so let's start with the first. Interchangeability of synonyms. So here I start with mila b'mila, which is the thesaurus we all know from of the Hebrew language. And the entries in the thesaurus are provided without any annotation. So as an example, up on top, we have the word mechakeh, and it gives us chocheh, chal, ma'amin, and so on. And then we have the word misayem to finish, where we have things like achron, gomer, and so on. Now, there's no indication as to which synonyms are complete replacements, completely interchangeable, which synonyms are partially, and if partial, then to what extent, and where are they applicable. And I think it would have been too much work for the editors of the thesaurus to do that. It's a monumental work in and of itself, but the users of the thesaurus need this information. So let's take two samples over here. For the word mechakeh, I'm going to take the word mamtin, both meaning to wait. And for the word misayem, I'm going to take the word gomer, both meaning to finish. So I took these two pairs. Now, we've seen a lot of these TSNE visualizations until now, but I'm making a switch right now. Until now, the colors have represented the automatic clustering done by my script. Now, I'm doing something else. I'm taking, in each graph, I'm taking 10,000 sentences of each of two words. So on the left, I take 10,000 instances of lechakot, 10,000 of lehamtin, and I'm coloring them based on the word. So there are 10,000 green dots corresponding to the 10,000 sentences of lehamtin that I took, and 10,000 red for the 10,000 sentences of lechakot. And those 20,000 sentences were all run through BERT. Then I ran the TSNE dimension reduction algorithm on those 20,000 as a single unit. But then I colored the dots afterward based on whether they had come from a sentence lehamtin or a sentence lechakot. And similarly on the right side, I've colored them based on whether they came from siyem or siyem or gamar. Now, I think what these visualizations do is that they show us immediately to our eyes how much overlap there is, or how much lack of overlap that is. And I think you see here, when it comes on the left side, when it comes to these two synonyms of waiting, lechakot and hamtin, there's virtually no no difference, meaning they're completely interchangeable. The way the graph works is that it writes the red dots and then the green dots on top of it. So the green dots are more dominant, but you can see red dots sticking out from virtually every area of the green, which indicates, which tells us right away that these two are just completely interchangeable, which is a very important piece of information. Now, on the flip side, on the right side, it's not like that at all. Siyam and Gamar are, the red and green are very distinct. There is an overlapping section, but there are definitely distinct sections, which tells us that these two are not exactly complete synonyms. They're not exactly interchangeable. Now the green, a lot of the green is usages of gimel mem resh, which are not a verb at all, like gimar. So that we'll put aside. But meaning the finals. But let's look at the difference between the exclusive red and the area where the red and green mix. Okay, the area where the red and green mix are cases like Gamar et HaMischak, he finished the game, or Siyem et HaMischak, or Gamar rak Beit Sefer Tichon, he finished only high school, or Begil 16 Siyem Tichon, at 16 he finished high school. Now, as opposed to that, the area where we just have red are things like, where red indicates Siyem, are Siyem Revi'i. In the race, he finished fourth, or Siyem Bimkom Chamesh, in Bimkom Chamishasar, he finished in the 15th place. Or Siyem Im 22 Nekudot, he finished with 22 points. Now, so what we see here is a very interesting phenomenon, which is that Gamar and Siyem, these two verbs, interchange with each other when they're used in a construction where they take a direct object. So like he finished the game could be Gamar et HaMischak or Siyem et HaMischak, or he finished high school, Gamar Beit Sefer or Siyem Beit Sefer, Siyem Tichon. But when it comes to something like Siyem Revi'i, he finished fourth. In practice, what we find is that that's used just about exclusively with the word Siyem and not with Gamar. We don't find Gamar Revi. I'm not sure why. That's something to look into further. But what BERT is telling us here is that the overlap is in this construction, in the syntactic construction, where you're giving it a verb, and not where you're giving it, not where it's coming with a prepositional, with some other sort of complement. And this is something that could be noted as a thesaurus companion to let people know how words would naturally be interchanged and how they generally would not in natural Hebrew. Okay, let's take. I'll do one more here, between rotza and chafetza, both synonyms for she wants. And here too, we see that the overlap is certainly not across the board. Now, some of the cases of the green is just cases of hu rotza, where it's used in the masculine and it wouldn't be relevant. But it turns out we have a bunch of other cases, like a koalitzia chafetza bikaram. Right? They want, they wish for their good, or ozrim lahem benefesh chafetza, with willingness. And these are collocations. These are phrases that use the word chafetza, but where it wouldn't be appropriate to substitute rotza instead of chafetza or chafetza. So this is the power. This is the first thing I wanted to show you. The idea that using BERT, we could build an entire thesaurus companion to let people know which synonyms, to let the readers know which synonyms are in fact interchangeable and which ones actually have various constrictions, at least in practical usage. Now, number two, editor's companion. There are a bunch of books that give editorial directives for Hebrew, books that tell us how we should shape our language. So one of the famous ones, one of the popular ones these days is Leah Tzivoni's book over here. And I'm going to look at 3 entries from Leah Tzivoni's book. The first is the where she says, don't say lo haya efshar, it wasn't possible. Say e efshar haya. Meaning they both mean the same thing, but she says it's more. Sorry, the opposite. she says, don't say e efshar haya, say lo haya efshar. This is her recommendation. Now, it seems from that we could just do a search and replace to change every e efshar haya to lo haya efshar. And the question is, are they really interchangeable? Right? I mean, she's telling us they are, but we're out to check this. So I ran the TSNE, and in fact, as you see here, the distribution is across the board. There's no we shouldn't have any qualms with interchanging the two phrases and replacing every efshar ya with lo haya efshar. Okay, but now let's look at the second one. Now she says ha'omnam, and ha'omnam should always replace ha'im be'emet. She tells us, don't say ha'im be'emet, say ha'omnam. Now, can we simply do a search and replace for ha'im be'emet and change it to ha'omnam? Right, ha'omnam. Can we really do this? Ha'im be'emet. Well, I ran the TSNE, and it turns out it's not so simple. There is a lot of interchange, but there's a lot of areas here. There's a lot of red where we don't have green, and vice versa. And so this needs to be constricted somehow. And the question is how? Well, we can just look at the sentences behind the dots and see. So when we look at the exclusive green zones, we find sentences like these. Ha'im be'emet u'v'tamim asazot. Did he really, really seriously do this? And similarly, the second sentence, where there's a collocation of ha'im be'emet u'v'tamim, and within that collocation, we can't just replace ha'im be'emet with ha'omnam. So this is a piece that we really have to warn the readers. We can't just do a search and replace for ha'im be'emet to ha'omnam, because then we would end up with ha'omnam u'v'tamim, which would not be correct. And BERT gives us this insight. BERT tells us these are the places that this does not work across the board, and these are the places that we have to watch out for. Okay, notice that we're working with multi-word phrases here. Until now, we've been working with single-word phrases. Now we're and the red zones, interestingly, the other way. There's also a restriction, which is although the places where omnam is used tend to be the same places as ha'im be'emet is used, there's one place where that doesn't work, and that is when it's used as a sentence in and of itself. If we start the sentence ha'omnam, if that's the entire sentence, then that's something we don't find with ha'im be'emet. If people want a single unit sentence that just asks, is that really true? Then they'll go to ha'omnam. And ha'im be'emet is something that would be used to start a sentence in the middle of a sentence, but in practical usage, it's not used as a sentence in and of itself. So another insight into the language from BERT, and another annotation that we could add to our thesaurus companion. And the third one, Baal Ofi, I see I'm running out of time, so I'll just say quickly, she recommends using Baal Ofi instead of Nosei Ofi, and she just sort of says it like that. But if here too, the overlap is not 100%, and what we see when we look at the exclusive green zones is that there is a place where Nosei Ofi is appropriate, and that is when we're talking about a nominal sentence. Right, so in her if it's being used adjectively, then her claim makes sense. Instead of Nosei Ofi, use Baal Ofi. But if our entire sentence is X has a certain characteristics like this, Yom Zeh, this day, Nosei Ofi has the characteristic of Hansacha, then we can't just put in Baal Ofi. I mean, theoretically we could, but the sentence wouldn't be very understandable, and it wouldn't be a natural way of speaking. So again, her comment here about Baal Ofi and Nosei Ofi really needs an annotation to say that's restricted to cases where we're using it adjectively. And the very last thing that I'm going to mention here quickly is the reader's companion, highlighting unusual word usages in a text. So until now, we've been focusing on individual words, but if you're probably also thinking, well, what if we just ran these algorithms on every word in a given text? Right, like here's a sentence from Agnon: Elokim b'shamayim yadat ma chova unitala min ha'olam. we can run every word here. And that's what I did. I ran every single word. One word is missing here. I have 7 out of 8 graphs. But I ran every word in a TSNE graph. And in each case, the word was assigned to one of the big clusters, except for the word unitala. That's an unusual usage. Usually those letters would be unatla, and she took. And here it's unitala with a verbal suffix, and he took her, which is an unusual usage of the word. And because of and that's reflected by the fact that the word was not assigned to any of the major clusters in the unitala graph. And what that tells us is that this is a weird usage. This is an unusual usage of the word. And what this allows us to do as a reader's companion is to take a text and pre-mark the text by highlighting the words that are being used in an unusual fashion, so that readers, especially school-age readers, can be told, watch out, here's something, warning, here's a word that's not being used in its usual way, so don't speed read through it, but stop and consider it, because there's something unusual about to hit you here. So that's a tool that we can use to help school children read, to help all of us speed read, to tell us when we can just rush through something and when we have to slow down. I ran it on a line from Savion Lebrecht over here. Haparot nitchaku sviva sakraniyot umitachat lehar bitna hamitnoea hitgalu v'nelmu chalifot. So this phrase is so what's strange here? I mean, the whole thing is flowery, but the when I ran the TSNE graphs, they highlighted the words lahar bitna, for the mountain of her belly, as a very unusual usage of both of those two words, which it is, in fact. It's a very creative usage. And on Google, I found not a single instance other than this one sentence from Savion Lebrecht. So finally, the embeddings, although, as I've shown, they can do miraculous things, there are places where they fail us, where the embedding space doesn't naturally split up according to the way we would have thought as humans. And it's important to know about these. And there are 3 of them: masculine, feminine, construct, absolute, and definite, indefinite. So I have here a map of row A and row A. He sees and she sees. And as you see, the dots are fairly interspersed. Meaning, amazingly, what I did here is I took a vocalized corpus that I had already vocalized, and the red dots are all the cases which were pre-vocalized as row N, the masculine, and the green dots are the feminine. And as you see, they are not clustered together in the space. They're not clustered into 2 different clusters, but they're all together. This is mind-blowing. Like, BERT is able to create these amazing distinctions between chalaklak as a person and chalaklak as a metaphor and chalaklak as a double metaphor. But it can't do the simplest thing that we as humans see when we see the sentence, which is to see the difference between the masculine and the feminine. Somehow the BERT embedding space is just not organized around that axis. Similarly here with ola and ola, meaning she goes up, he goes up. So too with absolute or construct. The word ma'archot, meaning systems, could be ma'archot with a shva, meaning systems of, or ma'arachot, which is systems in the absolute. And as you see here, although there are some clusters that are one or the other, meaning there are some collocations which BERT recognizes and clusters, and then de facto we end up having a cluster that's either construct or definitive. But overall, the embedding space is not arranged around the axis of absolute construct. And finally, the definite and indefinite axis is also one. When we have a bet or a kaf or a lamed, a prepositional prefix in the front of a word, that preposition swallows the definitive hey, if there is one, the definitive marker. So there's an ambiguity. Anytime we have a bet, kaf, or lamed prefix at the beginning of a word, is it in the definitive? Like in this case, tkufa, season, is it bit kufa in a season or bat kufa in this season? And here again, I took a pre-vocalized corpus, ran it through BERT, and as you see, it's not very differentiated. And similarly here with biome or biome, here it's a little bit more because we have things like biome shlishi, which are always going to be non-definite. But the point is that BERT ends up not creating those definitions. So it's important to know what we can rely on BERT for and where we have to pull back and say, BERT, you know, there are things that we need some other system or some other classifier for. Okay, so I hope, let me unshare my screen so you can see me. Okay, so yeah, so I hope I've managed to convey to you how the amazing power latent in the raw BERT embeddings, where if we go beyond just the masked language predictions that are so often used with BERT, and we look at the actual embeddings and we start working with them in the embedding space, there's so much power that we can extract from that, and so much utility that we can extract for language resources. And like I said, we just have to make sure to know beforehand whether we're playing to BERT's strengths or not, whether it's the type of thing where BERT distinguishes the syntactic and semantic distinctions versus the subtle morphological distinctions like masculine, feminine, where the space is not prearranged in that way. Thank you.
Thank you very much. Questions, please.
Avi, it was amazing. I enjoyed so much. Do you think you will be able to publish this as a tool, as a ממשק משתמש, user
Oh, I
interface?
certainly hope so. Yeah. The question is exactly what should be published and exactly how, and I don't, there's so many different possibilities here and directions. So like what would you like to see as an interactive tool?
Yes, I can tell you, because I had a lot of experience with people who have dysgraphia, which is a condition when a person cannot write correctly, and he doesn't see mistakes in the text. And this is really making life much harder. And for example, for Hebrew, for English, we have a wonderful spell checker, which solves the problem. However, for Hebrew, it doesn't work. And it doesn't work for the simple reason because it doesn't understand how the combination of a combination of letters has to be interpreted. And when you said that your BERT is narrowing down the combinations, like which one is more often used and which one is rarely used, actually, I think this can very much help and solve this problem, and this will be really a great thing because it's a condition that many people have. Do you think it is possible somehow to
Absolutely. Yeah, I'd really like to take it that direction. In fact, where you're talking about a better spell checker that has awareness of the context. I mean, that's something. I'll just share my screen for a second because you actually keyed into something that I had prepared, and then I saw there wasn't enough time, so I left it out. But there's this same method can be used to identify mistakes, right? I think you probably intuited that as I was working. So like here I took the words niftar and niftar, two very different verbs, one meaning passed away and one meaning solved, but very often confused because one has the taf and one has the tet, and they sound the same. And then I did that same sort of plot that I've been doing like with the synonyms, but here I plotted all the instances, or 10,000 instances in the corpus of the tet and 10,000 instances of the taf, and they cluster nicely, which is not surprising because they're so different. But what's interesting is that we have cases, see these little green dots in the middle of the red? So if we take one of those green dots in the middle of the red and we look at it, I mean, I just took one at random and clicked on it, and then I saw it was a piece from the Haaretz newspaper where they said, כשאביהם חלפון נפטר בפתאומיות, when their father Chalfon died. And it's there, it's from 2005, but it's still there on Google. I found it in Google yesterday. It's still there live on their site. They never fixed it. Or here's another one from Wikipedia, which said that this fellow died also with a tuff, and this was actually fixed. Wikipedia gets updated, so that was fixed since when I ripped it in 2018 when I downloaded the corpus. And then we have the opposite case of a piece from Walla Chadashot, from the news at Walla, לגבי העוני שלא נפתר. For the poverty, they meant to say was not solved, but they said had not passed away. And this power emerges from that same sort of clustering and visualization, where we see where we map them out, and we see words that we expect to be in one cluster and end up in the other cluster based on how they're spelled, are very often spelling mistakes that wouldn't be caught by a spell checker, because they're spelled they're spelled in a way that is certainly proper according to the dictionary. It's just that it's the wrong usage. And we could do this with anything, with El and Al, Aleph and Ayin, with Im and Aim. Sorry, with Im, where people switch the Ayin and the Aleph. I have instances here of Kehen, Keha meaning blunt and Keha meaning dark, and they switch, or instead of nikui, cleaning, as opposed to nikui, like knocking off. Anytime we have words that are frequently switched, we can build a model like this, which very quickly identifies the cases that are mismatched. So yeah, and what's latent within that is an option for a much improved context-based spell checker, and even a grammar checker for Hebrew. Yeah.
This is amazing. As they said in the 19th century, this will be a great service for the humanity. Any other questions?
May I ask a question?
Yeah.
Sure.
Hi, thank you very much for the lecture. Do we have a little bit more kind of maybe thumb rule to forecast if BERT embedding is good for some specific task or no? Because you mentioned the pro and at the end the cons, but eventually when I need to apply some solution, how can I know a priori if BERT will be good or not?
Well, I think I gave you the ground rules emerge from the lecture, which are that syntactic differences, like difference between a verb and a noun, or even mimena as a preposition or as a relativizer in preposition. Any syntactic division like that is going to be usually strongly represented. And semantic definitions like metaphor versus literal usage is also tends to be well represented and well differentiated in the BERT space. But subtle definitions on the morphological level tend to be not well differentiated in the raw space. It doesn't mean you can't build another classifier on top of it to hone in on the dimensions that would give you that information, but the raw space won't provide that information. The raw space is going to mix up the masculine and feminine and differentiate based on the metaphor or literal, or based on very different semantic context. The only thing that you'll get, I sort of hinted to this in the middle, is that if you have very specific collocations that recur again and again, so those will tend to get their own cluster. So if you have something like I mentioned, the verb rotza, meaning he wants, versus rotza. So if you have a collocation like hu rotza, we have a lot of sentences that start he wants, hu rotza. So that's going to get its own. That'll be clustered together because it's a very solid cluster, a very solid collocation. But other uses of rotza where it's just in the middle of the sentence without a pronoun beforehand, won't be clustered there, and they'll be clustered together with rotsa based on the semantics overall. That's my experience, but this is a new area. I mean, it's the space is huge of the BERT embedding. So there's this so much more to do to really research this and pin it down.
Okay. It's kind of surprising because when I say he or ta, so usually the words in feminine and masculine doesn't just appear alone. You will have some pre-word or post-words that kind of reflect that it's a masculine or male or female. So I would think that it would be catched by BERT. Okay, it's not just the word itself. Usually there's some kind of context around it. So it was kind of surprising that masculine and feminine was not perfectly clustered. So
Yeah,
that's what.
Oh yeah, I mean the entire thing is counterintuitive. It's shocking on both sides. Meaning, I was shocked that it was able to find those fine syntactic definitions, like the different usages of mimena. When I saw it, I was, I couldn't believe it. And on the flip side, these everyday definitions of masculine, feminine, or construct, absolute, I was sure that I would be able to rely on BERT in order to make the differentiation. And I saw time after time after time in dozens and dozens of words that it just couldn't do it. So yeah, surprising on both sides.
That's really surprising. By the way, the halakha example was awesome.
Thank you.
Three level of distinguish. Okay, thank you.
Okay, thank you, Avi. It was really awesome. It's extremely impressive. Thank you so much. And we have to finish now. It's 2:02.